Hello friends, very good morning. Myself Professor M.H. Annaya, and in today's video we are going to learn about the development of the lateral surface of a pentagonal pyramid which has got the side 30 mm and the height measured from the vertex to the center of the base as 60 mm. It is resting on HP on an edge of the base. So that edge of the base with an edge of the base normal to view. Friend, just listen. There are 5 shorter edges for the base and 5 slanted edges for the pentagonal pyramid. Now, first of all, we should see how the object is to be placed on HP. It has to be placed such that one of the shorter edges is normal to VP, and we have to obtain the top and front views of the pyramid. So friends, let's draw the XY line representing the line of intersection of VP and HP. So this is XY line, and VP and HP above and below this line indicates the first angle projection. So now I am going to write down the top view of the pyramid, which is a pentagon with the center O joined to all the corners. So friends, let us construct a pentagon to start with, and we will mark these sides of the pentagon as A, B, C, D, E. So this is having a measurement of 30 millimeter, and we'll name these corners as A, B, C, D and E. Friends, we will obtain the center of this pentagon by bisecting any two adjacent sides. Friends, here you are going to get this O, the vertex or the center of this pyramid, and join to this center all these corners. Center to A, B, E, then D. Finally, we are going to join this C. So friends, we have drawn the top view of the pyramid resting on its base on HP with one of the side AB is normal to VP, or AB is perpendicular to VP. Let us obtain O. This is O, the vertex, and by projecting these lines onto XY, you will get this as A dash, B dash, C and E come together, that is C dash, E dash, the last point is D dash. We have the center here. So through the center, we will write a vertical line, and above this, it represents the axis, and we will mark it as O dash, O1 dash, and the height of this pyramid is given to be 60. So this O dash is marked at a height of 60 millimeter above HP. Now let us join the vertex to all the corners, that is O dash to A dash, O dash to B dash, O dash to C dash, and O dash to D dash, O dash to E dash. Friends, here you can see the pyramid is resting on HP on its base, and then one of the shorter edges of the base is perpendicular to VP, and we have drawn the top and front views of the pyramid to the given dimension and also to as per the requirements of its placement. Now friends, let us learn about the section plane, how the object is being cut. It says it is cut by a section plane which is normal to VP. So what's the meaning of that? The section plane which is slicing or cutting this into two pieces is normal to VP, means perpendicular to VP, and hence it is seen as a line in the front view. Anything perpendicular to VP is seen as a line in the front view, and inclined at 45 degrees to HP, passing through an edge of the base. So friends, the section plane should be at an angle of how much? It is 40 degrees, and it should pass through one of the base edges. Friends, if you take this as the base edge, it has to pass through this base edge A, B, say A and B are the base edges, and it should be inclined at an angle of how much? 40 degrees to HP. So friends, I am going to draw the section plane, that is a line inclined at an angle of 40 degrees passing through one of the base edges. A dash B dash is one of the base edges. I am going to draw the section plane passing through that. So I will call this section plane as S1, S1, and it is cutting the solid into two pieces. So this section plane is inclined at an angle of 40 degrees to HP, or the horizontal. And friends, let us see which are all the points where the section plane is cutting the solid. Friends, it is cutting this slant edge O dash D dash at this point. It is cutting OC and OE at this point, and it is passing through A and B. So in the development, you should get 2 points for the base A and B, 2 for this OC and OE, and 1 for this. So it is cutting 3 slant edges, OC, OE, and OD, and it is passing through A and B of the base. Now friends, to draw the development of this, we need to have the true measurements of the base edges and the slant edges. You know very well, all these measurements AB, BC, CD, DE, and EA are true measurements. And to obtain the development, we have to obtain the true length of all these slant edges. Remember, true length of all these slant edges will have the same dimension. So friends, here, if you observe in the front view, O dash D dash represents one of the slant edges. I will write down here, slant here. It is one such, there are 5. It is one of the slant edges. And the corresponding top view for O dash D dash is OD. OD is the top view. And you observe friends, this top view OD is parallel to XY or parallel to VP, and hence this slant edge will give you TL. TL means true length. So this is the true length of all the slant edges. Now friends, let us move on to drawing the development. I will mark the vertex O, and from there I am going to mark this true length O dash D dash. A line as a perpendicular or anywhere you can just write down. So I am going to have this true length. I will say TL. Once you have this true length, friends, you can take O, the vertex as center, and this as radius, and you can draw an arc. So you are going to draw an arc with center O, length is equal to 2L, an arc is drawn. Friends, it is a pentagon. Pentagon will have 5 base edges, all these 5 edges, and all these have same measurement of 30 mm. So on this arc, I am going to step up 5 distances, each of length 30. So this is 30, second, 30, third, 30, fourth, 30, and fifth, 30. So friends, these are all the base edges. And you know friends, these base edges are always straight. That is, they are horizontal or straight to say. So I am going to join all this by thin line to start with. Because for all the pyramids, cubes, these will be straight edges. Now friends, I am going to join the last division here. Last division of this to this point. And let's also join this vertex O to all these corners. So this is one such, this is the second one, this is third one, this is fourth one, and that's the fifth one. Now friends, this measurement we have got is also the true length. So this length and this length are same. Now let us move on to marking of the points on the development. Friends, the section plane is passing through A, it is passing through B. And before that, you will have to decide how to mark these slant edges. Is it from OA or OB or OC, etc. Friends, if you observe, we are retaining the upper part of this above the section plane. We have been asked to draw the development of the lateral surface of pyramid containing the vertex. So vertex is O dash. So in the development you should have this O dash. So friends, this portion I am going to retain, and hence I will show this by a dark lines. So these are the dark lines you have got, and this is the section. So we want the development for the upper half. The lower half is thrown out. And if you observe the front view, friends, here none of these five slant edges have been removed totally. Only a part of OD, part of OCOE is removed. And hence, in the development, we have the provision to start from any one of these edges. So friends, let me say I am starting with this OD. So D will come here, then E. After E, you will get A, B, C, D. A, this is B, this is C, again D. The last two lines should have the same marking. Now friends, let us start drawing the development. So here, section plane is passing through A and B. Friends, A is here, is 1 point, B is here, so you get 2 points. Then friends, OC and OE are cut here, but OC and OE do not represent the true length. Hence, that point should be shifted to the last line, that is the true length line, and we take this measurement on OC and OE. On OC and on OE, we take equal measurement. So this gap is equal to this gap. Friends, so it is cutting these two slant edges. Again, this slant edge OD is cut here. So OD is the true length. So directly I take this measurement and mark on OD. So OD. Directly above that, again OD to be marked here. So friends, now the bottom portion is removed and the top portion, that is in the development, you are going to have complete OA, complete OB, complete OA and OB. So this is OB, this should be a dark line, and OA should also be a dark line because that portion is retained. And this also should be, because when these two edges are there, the base will be there. And then friends, we have got these points here. Let us join all those by straight line. By straight line. And this portion on OD is removed. So this portion does not exist. On OE, the bottom portion OE is also removed. So this is not existing. And EA is also not existing. And friends, here, when OD is not existing, even this length is not there. So friends, let us join and see what is the portion left over. So on OE and OB, it should be complete line. On OC and OE, the bottom portion is not there. OC and OE, this portion is not there. So this portion is left over. And this is your having this portion. And friends, what are the other portions you have got here? Then if you just observe closely, OA is existing. Yes, you have marked OA. OB is existing. Yes, you have marked O. Vertex is there. And then portion on OD is there. This is existing. And friends, on this, what do you have got? OC and OE. Bottom portion is removed on OC and OE. This portion is removed. And OE also, this portion is removed. And we have to join these two, this point here. that is OB is there. I have joined O to this, and what about this? This O to E, bottom portion O to E is not there, and O to D is not there, O to C is not there, this portion is not there, and here this A and B completed is there, this bottom is not there. So friends, if you join this to this portion will give you the development of the lateral surface of this pyramid. And friends, you can see here, in the development, we should have complete A and complete. And just a verification I'm doing. Complete A, OA should be there and OB should be there. And on OD, the upper portion should be there. OD, we have got this portion is existing. Then on OC, you should have this much of length above that. So this is on OC, it should exist. And then friends, in the bottom, this portion is not there. So all these are removed. The portion from here to here does not exist. When this is not there, this does not exist. And friends, this will give you the development of the part P shown in figure. This is development of the part P, which contains the vertex. So friends, I hope the presentation on this pyramid whose development is done or a part which has got the vertex, and this is being cut by a section plane S1 S1 at an angle of 40 degrees to VP, 40 degrees to the horizontal, and this is how you get the development. Friends, I hope you are happy with the presentation on this pentagonal pyramid cut by a section plane inclined at 40 degrees to HP, passing through one of the slant edges or the base edges. If you are happy with the presentation on this pentagonal pyramid, please share the information with all your friends and have a wonderful day.